And my project was Tensorflow for neural collaborative filtering. So first I want to talk about just the overview. I'm going to define what collaborative filtering is. I'm going to talk about what my project was, and I'm going to discuss some of the lessons I learned. So collaborative filtering is an algorithm that companies like Amazon and so on and so forth can use to recommend products to you. So in this example, Amazon's recommending shoes to you. So what they're going to do if they're using collaborative filtering is they're going to compare you to other users across items across your item behavior space. And so in this example, we're just going to look at items that we've purchased. So if I've purchased basketball shorts and a basketball, but I haven't purchased a leotard, they're going to look at this third user and go, okay, this guy's really similar to this other user with the green shirt, and we're going to use this user that I'm similar to predict uh, what products that what product they should recommend to me. So if this user didn't like either of these two shoes but like the third one, that's what they're going to recommend. So that's the collaborative filtering algorithm. In this instance, we're just taking that collaborative filtering algorithm and we're putting it into a neural network. And so I based my entire project off of that paper. The model was open source. In the paper, they use MovieLens, the MovieLens dataset, which is users, movies, and ratings of those movies. And the paper actually converted those to just was it rated or not. And you might say that doesn't give you information as to whether or not the user liked the movie. But believe it or not, if you want to see two users that are similar, you can just see if they rated an item or not, and that actually gives you a lot of information about user similarity. Here's an overview of the model that was used. We see that we're taking a user and an item vector and we're converting them into an embedding, similar to how Word2Vec converts just individual words into word embeddings. And again, we're taking these embeddings, we're feeding them into several fully connected layers and using them to predict, again, whether or not that user rated a specific user rated a specific item. And so what did I do for the project? I just converted this KRS model into a TensorFlow model. The KRS model is what is KRS? It's just a higher level of abstraction, just like TensorFlow is a higher level of abstraction on top of something like MATLAB. And so I learned a few lessons in doing this. So here's an example of Keras. And the first lesson that I realized is that if you're going to build a model and you want to build it quick, Keras is the way to go. It's just super easy. If you wanted to find an embedding layer, for example, this is it. You just define the inputs, the outputs, the initial how you want to initialize your weights, how you want to regularize your weights, and that's really it. The code is just very it's not like just very straightforward and quick. On the TensorFlow side, I mean, this is what you have to do. I mean, you got to define the embeddings, you got to define the embedding lookups, you have to look up the define your activation function, define what your weights are, define what your biases are, so on and so forth. It just takes a lot more time. So the second lesson is that Keras actually helps with organization. So even though you have to define all this stuff and it's a lot more explicit, it just takes so much more time, and it's really hard to tell. Like, you don't really see just by looking at this. This is like the code that we're using to define the embedding layer. Whereas on the Keras side, like, okay, yeah, this is the code that's being used to define the embedding layer. The class name is called embedding. It's just very obvious. So Keras helps with that organization. It also, because we're putting the regularization type and the weight initialization all within this layer, it's just very organized. We know what's going on in that layer. But at the same time, TensorFlow is more explicit. I mean, again, because here we have to define everything that's happening here. So, if you want to customize things or if you want to tweak things, TensorFlow is the way that you want to go. Keras, a lot is just defined in these default parameters that you might never see. And so, TensorFlow is far more explicit. And so you might say, well, if I wanted explicit, I'd just go with MATLAB or Octave. And while that's true, I think the same lesson applies. If you want more customization, if you want less abstraction, you have to go to a lower level of abstraction. But if you want to be able to, build a model very quickly, TensorFlow is the way to go. And if you want to build it even faster, Keras is the way to go. So that's all I got. Thanks for watching. The 5-minute limit is pretty tight. So I'm not going to discuss results again, those were in the paper, but if you want to check out my model, it's on GitHub, as is the open source model that I base mine off of. So thanks for watching.